Question 4 asks you to determine the first derivative of each of the following functions. Print your answer in the box provided. You do not have to simplify your answer or explain your steps. So I'm going to write in pink on each one of these what rule I'm invoking before I take the derivative. So this is set up in a way where all I have to do is apply the power rule. So the derivative of 7x to the 5th is 35x to the 4th. The derivative of x to the 3/5 is 3/5 x. I need to subtract 1 from this fractional exponent, and the shortcut is subtract the denominator from the numerator to get your new numerator. So 3 minus 5 is -2. So it's -2/5. Then the derivative of 2018 is 0. So that's it. That's our final answer. For the next problem, I can see that I have a rational expression. So I'm going to use the quotient rule. And the quotient rule says the derivative of a quotient is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. So for this problem, the derivative of the numerator is e to the x times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. You can technically stop here, but if I were to factor the e to the x out front, that would leave me with x squared minus 2x plus 5 over x squared plus 5 quantity squared. So I'm going to write my final answer in the box provided. This next problem involves a product rule. But if I sort of peek ahead, I can see that when I do the derivative of this piece of the product rule, that's going to require a chain rule. So the product rule says if you have two functions being multiplied together, it's the derivative of the first times the second plus the first times the derivative of the second. You can also write it the other way around because all we're doing here is adding, so doing these in any order is perfectly fine. So the derivative of the first piece is 9x to the 8th times the second, which is cosine 4x, plus the first term times the derivative of the second, which is negative sine of 4x times 4. So if I just clean that up ever so slightly, I'm going to move the negative sign out front. I'm going to bring the 4 out front. And this is my final answer. The last problem is an arc-trig function, but I can see here that this piece is going to require a chain rule. So before I take the derivative, I'm going to rewrite this with fractional exponents because it's easier for me to take the derivative if I use fractional exponents. So now the derivative of the first piece is 1 over 1 plus x squared. That's the derivative of arctan. This is going to require a chain rule. So the derivative of the outside is 1/2 x squared, or x to the 7th, plus 3x to the negative 1/2 times 7x to the 6th plus 3. So when I write my final answer, I just find it easier to go back to positive exponents. You can technically stop here, but I'm going to get plus 7 x to the 6 plus 3 in the numerator, and in the denominator I have 2 times the square root of x to the 7 plus 3x. But it's perfectly fine to stop here. And if I had not written an f prime of x here, that would have been an improper use of equal signs. It would have looked like I was trying to say the derivative was equal to the original function, so let's be careful and watch out for stuff like that.